Chapter 10, Constructions. Today we're going to cover Section 10.3, Concurrent Lines. The class opener. Draw a line and a point not on the line. Construct a line through the point that is perpendicular to the given line. Our objective for today. After studying this section, you'll be able to state and apply theorems involving concurrent lines. Our first problem, construct all angle bisectors for the triangle. Well, I know that for constructing angle bisectors, the first thing I should do is put the point of the compass at the vertex, open up my compass, and swing an arc. And since I'm doing all of the angle bisectors, I'm just going to do all of them at the same time. So I'm going to swing an arc at the vertex for every single angle. And this one I think I'm going to open up a little bit bigger. And it doesn't matter how big the arcs are, just swing an arc at every vertex. Okay. The next step for doing an angle bisector is from each of the points where the arc you drew intersects the side of the angle, you need to swing an arc out in the middle of the angle as long as the arc is larger than halfway going across. So if I swing an arc out in the middle here, and from the other side, I'm going to also swing an arc out in the middle, and I'm just going to keep doing that all the way around, and I'm just going to even keep the same dimension on my compass, even though you don't need to. And then to finish up, I just need to draw in my lines. So from the vertex through the point of intersection, and I'm just going to extend it all the way to the opposite side of the triangle. Vertex through the point of intersection, I'm going to extend it to the opposite side of the triangle. Vertex through the point of intersection, going to extend it to the opposite side of the triangle. So there are all three angle bisectors. It says, draw a line from the intersection perpendicular to a side and use this distance for the radius of a circle. All right, so now I want to go from this sort of point, I'm going to call it the center of the triangle, and I want to measure a distance perpendicular to one of the sides of the triangle. I'm going to try to do that measuring perpendicular to the bottom. So what I'm really sort of thinking in my mind is, how would I do this if I had just a given line and a point not on the line? How would I construct the perpendicular through that point? So doing that inside the triangle, the first thing I'm going to do is put the point of my compass at this center of the triangle. And what I need to do from there is mark off so that I can hit two places on the bottom of the triangle. So there's going to be one mark over here sort of to the down and left, and another mark over here down and to the right. Then from each of these new locations I swing an arc, one below the triangle, and if I swing one up above, since I haven't made any changes, should go right through the point that I care about. And then doing the same thing from the other side, swinging an arc up above and swinging an arc down below. And if I connect that together, I know that this is now perpendicular to the triangle. And what the problem had asked me to do was draw a line from the intersection perpendicular to the side, did that, and use this distance for the radius of a circle. So it's really saying, take the distance from the center to the edge of the triangle and use that for the radius of a circle. So let's take my compass, put the point back in the center of the triangle, measure out the distance to the edge of the, and if I spin a circle, and if we did all of our measurements correctly, you should get a circle that it fits right inside of the triangle. Construct the perpendicular bisectors for the sides of the triangle. Well, I remember for constructing the perpendicular bisectors, I put the point at one end of the segment, I open my compass up so that it is larger than halfway, and I swing an arc. So I swing an arc from this side, and then I just need to swing an arc from the opposite side as well. So the perpendicular bisector will be the segment that connects those two pieces together. So here's my perpendicular bisector. And I'm just going to continue to do that to the other sides as well. So if I try to construct the perpendicular bisector for the sort of top right side, I just open my compass up to make sure that it's more than halfway. Swing an arc, and I do that from each side of the segment. And if I connect those together, I get the perpendicular bisector of that side. Since it's starting to get a little cluttered, I'm going to clear out some of these arcs that I was drawing to figure the perpendicular bisectors, just to make it a little bit easier to see everything that's sort of left behind. All right, so here's my perpendicular bisectors. I still need to do the perpendicular bisector for the sort of top left side. So if I put the point of my compass there, and if I swing my arc, and if I repeat that from the other side, I know that my perpendicular bisector will connect the two intersection points. And just like before, just to make it look not quite so cluttered, I'm going to erase out the arcs that I drew. And for some reason, this one won't quite cancel, so we'll leave that one in there. Let's see. Draw a circle with the intersection point at the center of the radius length from the intersection to a vertex of the triangle. All right. So it looks like my perpendicular bisectors, I didn't quite draw them long enough, so let me extend them out just a little bit more. Okay. So now what I'm supposed to do is measure from this intersection point to a vertex of the triangle. And it didn't say which one, so I'm just going to pick the one on the top and draw a circle. So let's see what happens. And I noticed it wouldn't have made a difference because it ended up hitting all vertices. So here I have a triangle sort of inscribed with each vertex touching the inside of a circle. Your closure. Name the geometric constructions you already know.